Hi students, welcome to my channel. This video useful for 8th standard onwards. Now I will explain potential energy. Simple definition: energy possessed by an object virtue of its position. Okay, one more definition also we can tell: the energy possessed due to the arrangement of system of objects. This is another definition. But these two definitions, I am sure you will not understand what actually meaning of potential energy, how it comes. Okay. So now I will give some examples so that you will understand very clearly what is potential energy. Okay. You know, if two objects have masses, because of gravitational force, they will attract each other. Agree or not? Simply, I am leaving this object, it is falling down because Earth is attracted by this object, or this object is attracted by the Earth. That is why it is moving towards the Earth. Okay. Now I am making an arrangement. Okay. Now you assume this is Earth. Okay. You assume this is one of the object. Okay. These two, initially they were like this because both are attracted, they are together. I am arranging these two some distance apart like this. I arranged. This arrangement possesses some energy. That energy is called potential energy. Because these two objects have masses, they have gravitational force. With that force, they will attract each other. If I leave this, it will come back and fall on this Earth. But I am not leaving this. I am arranging these two, maintain some distance. This arrangement possesses some energy. That energy is called potential energy. You got it? This is class number 79. Potential energy. Energy associated with the arrangement of a system of objects that exert forces on each other. Second point, potential energy can be thought of as stored energy that can be converted to kinetic energy or that can either do work. Now I will explain conservative forces. What is meant by a conservative force? Okay, see here, I am throwing this ball upward like this. Means I have given some kinetic energy initially to this object to move upward. As it is moving upward, the velocity keep on decreasing. Means as it is moving upward, the kinetic energy is decreasing and potential energy is increasing. Whatever kinetic energy decreasing, that will convert into increasing potential energy. Okay. This kinetic energy is decreasing because of one force is there downward. The downward force is gravitational force, that you know. Because of this downward gravitational force, this velocity is decreasing and kinetic energy is decreasing. Okay. So, this force is called conservative force. In what way this force is special? You see here, I am throwing this ball vertically upward. The kinetic energy is decreasing. After some time, it will reach maximum height and it will stop and it will come back. When it is coming back, this object regains its original kinetic energy. Okay, this is the specialty of this force. Because of this force, this kinetic energy is decreased. Because of the same force only, the kinetic energy recovered back. It has got its original kinetic energy. So this force is called conservative force. So basically this force is doing some work. This work will not depend on path. It will depend only on the initial position and final position. Suppose it has moved from here to here. It is moving from here to here. What is the work done? It is same as, suppose it is moving like this. The work done is same because initial position, final position is same. So it is moving like this, it is moving like this, or it is moving like this. In these three cases, work done will be the same. So for these cases, what is the force acting in these situations? That force is called conservative force. Example is this gravitational force and restoring force in the spring. Spring is there, no? Attach one end to one wall, another end attached to one object. You compress it, one force will be restored. After that, it will repel back, no? Otherwise, you elongate it, it will come back. It will oscillate like this, no? The restoring force in the spring also called conservative force. See here, conservative forces. I will give some important points about conservative forces. First one, a force is conservative if the work it does on a particle moving between any 2 points is independent of the path taken by the particle. You see here, between the 2 points, point A and point B, this particle is moved from here to here like this. This is path 1. From here to here it is like this. Path 2, it has moved like this. In path 3. Okay. Total 3 paths. This one, and this one. Work done here W1, work done W2, work done W3. The force direction is along this direction, A to B. So the work done W1 equal to W2 equal to W3. That's what I want to say. The conservative force means the work done by that force, it is independent of the path it followed. So in these three paths, work done is same. W1 equal to W2 equal to W3. Okay. Second point, you see, the work done by a conservative force on a particle moving through any closed path is 0. See here, the particle started from point A. From here it has started. It has moved, it has come back to original position. Work done by the conservative force is 0. W equal to 0 because total displacement is 0. Okay. I will give some examples for conservative forces. Okay. The first one is gravitational force. It is a conservative force. Second one, restoring force. Restoring force means not only force that spring exerts on any object attached to the spring. Take the spring and one side attach it to the one hinge, another side attach one object. You compress it or elongate it. The spring exerts the force on the object. That is also example for conservative force. Okay. Now we will discuss non-conservative force. In the conservative force, you understand just before I explain. In the non-conservative force, because of this, there will be loss in mechanical energy. What I want to say, whatever the energy lost, you cannot get it back in the original form. In the previous example, I have thrown ball upward. The kinetic energy is decreasing. Kinetic energy decreasing. After some time, it is coming back, and I regained the kinetic energy. But in the non-conservative forces, this energy we cannot get back. There will be loss in mechanical energy. That will be appeared in the form of heat. It is simply due to a force of kinetic friction. Okay. Suppose you see here, this is eraser, this is one surface, a book. Okay. Now I am giving some velocity to this object. What happens? It will move some distance and it will stop. I am giving, you see here, I am giving some velocity. It is moving some distance and it is stopping. Why it is stopping? Because of the force of kinetic friction. It will oppose the motion of the object. means the kinetic energy is lost. There will be loss in mechanical energy. So this energy will be appeared in the form of heating of these two objects, this surface and this surface, both are in contact, no? So that energy will be lost to appear in the form of heat. Okay, when it is coming back, you will not get back the kinetic energy. Initially it is moving with some kinetic energy, no? It has stopped. But after, when it is coming back, no? It means that heat you cannot use. That heat you cannot use back to increase the kinetic energy. So this force is called non-conservative force. Example is force of kinetic friction. In fact, it depends on path. The energy lost will be different for different paths. Suppose it is moving from here to here, what is energy lost is different if it is moving from here to here. Even though initial position, final position is same, from here to here it is moved. What is energy lost here? It is less compared to when it is moving from here to here, because the path is bigger. When path is bigger, the energy lost will be higher. Okay, this is example for non-conservative force, that is force of kinetic friction. Got it? See here, it is a new topic, non-conservative forces. Previously we discussed conservative forces. Work done is independent of the path, but here it is completely opposite to the conservative forces. That is why it is non-conservative forces. A force which causes a loss in mechanical energy is called non-conservative forces. I will give some example, you will understand. Otherwise, by reading this statement, you will not understand anything. What it is meaning? Force of a kinetic friction, you see, when object is moving on another object, kinetic friction comes into the picture, no? So this force of kinetic friction is example for non-conservative forces, because the loss of mechanical energy due to force of kinetic friction depends on the path of the object followed. Here the work done, or what I want to say, from here to here it has traveled one path between the point A and B. So from here to here travel. These two paths you observe. So the object lying on a surface, there is a force of kinetic friction, no? So certainly when it is moving from here to here, the loss in energy is more, because this path is bigger compared to this path. So this is del E2, the loss in mechanical energy, and this is del E1, loss in kinetic energy. This path is small, that's why the loss in total energy or loss in mechanical energy is small. So I can write one inequality, del E2 greater than del E1. So when the object is moving from here to here, if path is bigger, the loss in mechanical energy is more. That loss in mechanical energy will be actually converted into heat energy. When one object is moving on another object, because of friction, the force of kinetic friction, there will be loss in mechanical energy that will be converted into heat energy. You cannot get back equivalent in mechanical form. That is why I am calling it as a loss. You got it now? The major difference is that only. Here, non-conservative force, it depends on the path. But conservative force, it is independent of the path. Okay, I hope you understood. Please like this video, share this video, and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos.